Hello, this is Team 4, and this is our Evidence 1, in which we will see subjects like the life cycle assessment in chocolate from Ecuador, proposal to attain sustainability, the application of the cocoa beans, and the design of a cleaning disinfection program, as well as the principle 1 and 2 from the HACCP system.
Our team has chosen the chocolate industry as our focus, considering its global popularity and projected growth in the international market. With a market value of $130 billion, it is estimated that around 5 million tons of cacao beans were processed in 2021 alone. The modern industrialized chocolate production involves a series of processes including fermentation, drying, roasting, grinding, conching, and tempering. However, certain byproducts generated during these processes, such as cocoa pod shells and mucilage, are currently discarded despite their potential value. To understand the environmental impact of the chocolate industry, a life cycle assessment was researched, and according to Bianchi et al., cocoa production, transport, manufacturing process, water consumption, and packaging all contribute to its overall sustainability. Cocoa production, in particular, faces challenges such as low yield, disease susceptibility, and the use of fertilizers and pesticides, which have adverse effects on global warming, acidification, and eutrophication. Transportation, specifically for cocoa cultivars to factories in different parts of the world, adds to the environmental impact, while the manufacturing process requires significant energy consumption, especially for producing milk powder and packaging materials that also play a crucial role. This is the mass balance of the process. Now, the chocolate production process generates various byproducts that are currently being discarded. Cocoa pod shells, which represent 67% of the fresh pod weight, contain crude fiber, antioxidants, and can spread pathogens. Mucilage, another byproduct, has industrial potential due to its sugar and mineral content, while cocoa bean shells, often thrown away, are rich in dietary fiber, have oil and cholesterol absorption capacity, and have a high protein and mineral content. The manufacturing process of chocolate requires a substantial amount of energy for electricity, cooling, heating, and specifically milk powder production. Although energy consumption is high, it's worth noting that water consumption is primarily significant during milk powder production. Chocolate production has well-documented environmental and social impacts. For example, approximately 70% of chocolate is produced in West Africa, where cocoa farmers are cleared tropical forests, contributing to deforestation. Moreover, child labor is prevalent in cocoa farms in Ghana and Ivory Coast, where factors lead to significant loss not only in terms of environmental sustainability, but also in terms of human rights and social responsibility.
This product has a lot of areas of opportunity because most of the residues can be used like a byproduct. In this industry has one of the most demand in these years. Just in 2021 had 5 million tons of cacao. We choose this product because it's one of the most important in our culture and it has a drastic environmental impact. The pre-processing it had place in Ecuador. We have harvest, fruit break, fermentation, drying, and storage. In fermentation, the acetic acid bacteria and the lactic bacteria acts to develop the flavor of the product. And in drying, it can be natural or with dryers. Then in processing, it had place in USA or Europe. We have roasting, peeling, greening, hydraulic pressing, grounding, filtration, mixing, conching, molding, cooling, and packaging. On limitation, we have the country of Ecuador. In functional unit, we use 1 kilogram of milk chocolate. And in dimension, we have upstream, core, and downstream. And this is our chocolate formulation.
Knowing the material inputs that go into the production of chocolate, it is essential to extract the most out of the products generated so as to minimize waste and loss. So here are 3 applications for cocoa bean shells. One alternative for cocoa bean shells is to extract their polyphenols, which can be used as antioxidants in fats, such as meat products or oils. These have been shown to be just as effective as BHT, butylated hydroxytoluene, and BHA, butylated hydroxyanisole, which are popular conservatives used in meat products to prevent rancidity. These compounds can be extracted using heat-assisted extraction or ultrasonic-assisted extraction, post-electric fields, microwave-assisted extraction, or supercritical fluid extraction. Cocoa bean shells can also be used as a fat replacement in baked goods, primarily due to their high insoluble fiber content, from 13 to 65%. It has been determined that fiber can replace around 50 to 70% of fat present in baked goods without any significant impacts on organoleptic properties. These products can be bread, cakes, or biscuits, and the bean shells contribute to a softer texture and also a higher fiber content and antioxidant content in the final product. The shells are also relatively cheap, and they're a good source of chocolate flavor and aroma due to their high concentration of volatile organic compounds. Another use for this byproduct would be the extraction of phenylated oligosaccharides, a type of cell wall polysaccharide. These are a functional group of compounds that are still being studied, but they show great promise regarding their effect on type 2 diabetes, anxiety, and depression through the regulation of the composition and the metabolism of the gut microbiota. The compound can be extracted through acid hydrolysis of several polysaccharides.
Okay, so before introducing the HACCP plan, it is important to approach prerequisite programs. Even though they don't control hazards, they are the foundation for the HACCP system, and it's important for them to be incorporated into chocolate manufacturing. Some of these prerequisite programs are food hygiene training for employees, proper design of facilities that involve mainly proper waste disposal and adequate ventilation. Another prerequisite program are tools and equipment for cleaning, and finally, food safety management systems. So, in order to be aligned with prerequisite programs, a cleaning and disinfection program was designed for the roasting equipment in chocolate manufacturing because this stage leads to the separation of the cocoa nibs and the cacao shells, which is the byproduct that it's been analyzed. The goal of the cleaning and disinfection program is to minimize the incidence of physical and biological hazards on this stage. The first step for a cleaning disinfection program, its procedure on this case is the cleaning and sanitation of the roasting equipment by using dry cleaning operations. The first step is brushing, then vacuum cleaning. After that, sweeping with disposable wipes, 70% alcohol, and finally the disinfection of tools. The frequency for this operation is before and after each shift by trained staff. After procedure comes the monitoring stage that consists of the revision of the roasting equipment through visual inspection. If a problem is identified, a corrective action has to be implemented, in this case, informing the production manager and stopping the production shift until the cleaning is done properly. Following the monitoring procedure comes the verification that can be daily, and it's fulfilled by revising the monitoring notebook, or it can be periodically, more commonly monthly, to identify biological hazards through laboratory analysis by using samples of the equipment.
HACCP is a systematic approach to identify, control, and evaluate food safety hazards. We will use Principle 1 and 2. Principle 1 consists of a hazard analysis like chemical, biological, and physical hazards, and Principle 2 is the determination of critical control points. This is the first principle in which we will analyze the food hazard. We chose the roasting step. Now we need to identify any biological hazard like salmonella. Does it need to be controlled? Yes. Why? Because salmonella can be found in chocolate and it can lead to an infection even in small concentrations. So what preventive control measure should be applied? We need to ensure an adequate temperature from 110 degrees Celsius to 140 degrees Celsius and an adequate roasting time from 0.44 minutes to 4 minutes. So is the preventive control measure applied at this step? Yes, it is applied at this step, at the roasting step. Now we will identify any chemical food hazards like fungicides and insecticides. Do they need to be controlled? No. Why? Because farmers should comply with the guidelines to avoid any pesticides contamination. So what control measures should be applied or can be applied? Good agricultural practices are used to reduce possible food losses post-harvest storage and production stage. Now, is the preventive control applied at this step? No. Last is the physical food hazards like stones, wood, metal, and glass. Does it need to be controlled? Yes. Why? Because they can cause physical injury, like cuts or lacerations to the mouth, throat, or digestive system, as well as choking. To prevent it, it can be identifying potential equipment failures and scheduling regular inspections. So, is the preventive control applied at this step? Yes. This is the method from the FDA that we will use to determine if it is a critical control point. First, we have the roasting step. Does it involve a hazard that needs to be controlled? Yes, a biological hazard like salmonella. Does a control measure exist for this hazard at this step? Yes. Is it necessary to control it at this step? Yes. Then it is a critical control point. Does drying involve a hazard that needs to be controlled? Yes. A physical hazard like foreign matters and biological hazard like salmonella. Does it exist a measure to control this hazard at this step? Yes. Is it necessary to control it at this step? Yes. Then it is a critical control point.
In conclusion, the chocolate industry can shift to a more sustainable model by minimizing water consumption, avoiding the use of agrochemicals, and creating strategies to limit transport between farms and factories. In addition to these improvements, cocoa bean shell can be used to develop added value products that can mitigate food loss and enhance public health. These are the references we used.